In previous courses, you have learned to evaluate expressions given the values for specific variables. Recall if you were given an expression and were told to evaluate and given values, we would substitute in the values and simplify. So here m equals -1, so we would substitute that in for m here. N equals 3, so we would substitute that in here. And p equals 5, so we would substitute that in here. In this expression, there are only constants, so we can evaluate and simplify to just the number -10. In this section, we will extend that knowledge to include literal equations and use substitution to solve for unknown quantities. The values of any variable in an equation depends on the values of the other variables. To find an unknown value, you can follow these 5 steps. Identify an equation if not given to you, which relates the values of the variables you know with that of the variable you don't. 2. Solve for the variable of interest. 3. Substitute numbers for the known variables using parentheses around each number. Using parentheses, I think this is one of the most important parts and is key when you're solving for unknowns. Then do the arithmetic to find the unknown value. 4, and finally 5, assign units to solution if necessary. Let's take a look at how these 5 work now with an example. Find the volume of water in a cylinder of radius 4 feet and height 6 feet, where V equals pi r squared h. It might be helpful to take inventory of all the information provided. So here we're given the equation, the radius, and the height. So remember, it's best to use parentheses when we make substitutions. So we're going to substitute in, we'll have V equals pi, but no longer r squared, we'll have parentheses 4 squared, and not h, our height is now 6. So here we will have volume equals, well, we can simplify 4 squared is 16 times 6 is 96 pi, and our unit will be feet cubed. Now the units were feet cubed. Why is this the case? Well, if we look at the formula, V equals pi r squared, pi is a constant, it has no units, but r squared is feet, inches, the height was in feet, so feet squared times feet is feet cubed. Here's another example. A car travels 800 meters in 480 seconds. At what speed was the car traveling? So identifying a useful equation is going to be speed equals distance over time. We now need to solve for the unknown. Well, here we are given the distance d and the time 480 seconds. So it's already solved for the unknown, which is speed. That's our unknown. We now can substitute the known values. So speed equals d is 800 meters. T is 480 meters. Seconds. It's seconds. It's time, so it's 480 seconds. We then want to calculate, so we can simplify 800 divided by 480 is going to be, our speed will be 1.6 repeating. And assigning units, well, we have meters over second. So the speed would be 1.6 repeating meters per second. Here's another example. A car travels at a speed of 75 miles per hour for 1.5 hours. How far did it travel? And identifying a useful equation, again, we can use speed equals distance over time, since in the equation, in the example, we're given speed and we're given time. Now we're looking for the unknown of distance. So we need to solve this equation for distance. So in order to get distance by itself, we can do some side work. We can multiply both sides by t to undo dividing by t. This would give TS equals D, or distance equals TS if we flip the sides. We now substitute for the known variables, so distance is going to equal the time, 1.5 hours, times the speed, 75 miles per hour. Calculating, we need to multiply 1.5 times 75 will give us a distance of 102.5, and our hours are going to cancel out, so our unit will be miles. Acceleration is also a common formula that we use and is found using the formula acceleration equals the change in velocity over the elapsed time. It takes the change in velocity over time. It's also read as A equals V minus V naught over T. So where do we hear about acceleration outside of class? We are used to speed, distance, and time, but acceleration is a fairly new word. You may have heard about acceleration when referring or relating to cars, roller coasters, gravity, or many, many different things that move in our world. You can derive the units for acceleration by substituting the correct units into the right-hand side of the equation. The change in velocity, the numerator, v minus v naught, is in meters per second. So here we're taking meters per second and we're putting that in the numerator. And time, t, is in seconds, and we're putting that in the denominator. So meters per second divided by second is meters per second squared, or meters divided by second squared. So that is your acceleration unit, is when it's the two of them together.